so lesson 1 was all about really where the middle is. Let me draw this properly. Lesson 1, where is the middle, or what we call central tendency. Okay, mean, mode, median. And then lesson 2 was about how spread out the data is. And we talked about things like the range, the interquartile range. We spoke about Q3, Q1, Q2, etc. And then at the very end, we started talking about percentiles. And so that's kind of where we're going to carry on from today. And then the other thing that we're going to do is, after working with percentiles a little bit, we are going to talk about another measure of spread. So today will be a little bit of the percentiles that's left over, and then we're going to do something called standard deviation. And what standard deviation is also a measure of how spread out the data is. And it's very common in science. It's a very useful measurement of how spread out data is. And then after that, we will do the 5-number summary, and we'll combine that with a graph called a box and whisker plot. We may not quite get there, but we'll try. Okay, so that's the goal for today. Okay, so let's start with percentiles. At the very end of the last lesson, we started talking about percentiles. And if I wanted, for example, the 80th percentile, we would call that P80. And in order to find the 80th percentile, we have to use a very similar idea to what we did with quartiles. So we find the position of P80 first, and then once we know its position, we can work out what the value of P80 is. And the formula we use to find the position for P80 is just whatever the percentile is, so it's 80 over 100 times n plus 1, where n is the number of items. So in this data set here, which we've used before, n is 29. Now, the only difference with percentiles to quartiles is when we find the position number with percentiles, we round off. So if I got, for example, 26.2 for my position, you round off to the nearest number, which would be 26 if it was 26.2. Whereas with quartiles, we were averaging it between the two nearest values. Okay, but let's just start with that. For my data set that I have on the board right now, so this data set here, what is the 80th percentile? I want you to work that out for me. And know that you have to start with finding the position of the 80th percentile. And then go from there. So what is the position of the 80th percentile? Now, this data set we've used earlier on, n is 29. So that's how many items there are. And it is arranged from smallest to biggest. So that's already been done for you. So what are we seeing as our position? So to me, the position looks like 24th position. And if I count to the 24th position, now it's going to take a while. 1, 2, 3, 9, 10, 11, 12, 13, 16, 17, 18, 19, 20, 21, 23. So I get that the 80th percentile has a value of 53 in the list. So notice there's two distinct parts with percentiles. It's finding the position of the percentile in the list. In this case, it was the 24th position. Then I had to count to the 24th position. I guess it would have been easier to go backwards from 29, but whatever. And then you get the value of the 80th percentile. And in this data set, the value is 53. Okay. Now, I know that a lot of you still need to practice this more. So I want to ask you, and you may have questions that you want to ask me now, but for those who are feeling comfortable, find me P65 or the 65th percentile for this data set. So I want you to take what you see on the board and use the structure that you see to find me the 65th percentile. And then while students are doing that, who has a question? Who would like to ask a question? Okay, so Loretta, if there's 19.5, we would go up. So we had sort of a little bit of a discussion about that at the end of the last lesson. If you get a 0.5, the convention with rounding is to round up in that scenario. If that is true, if it is 19.5 is the position. And in fact, I'll even say what is P88 as well, just to make sure you've got the percentiles down. Yeah, so because it's 19.5, we're going to say it's the 20th position. So we round it up. And so this is important. This is the difference between quartiles and percentiles, where percentiles, we're rounding off using the normal rules of rounding. Where is the 20th position? I guess I'm going to have to do some more counting. 1, 2, 3. 15, 16, 17, 18, 19, 20. And so the 65th percentile is going to be that number. What is that number? And you have to use the stem and leaf plot. So it is going to be the 65th percentile is going to be the value 34. And again, if there are questions from the class, please do raise your hand. I'm quite happy to answer them. And so, to point out kind of what this means, if 34 is P65, you can see most of the data is below P65. In fact, not just most of it, 65% of the data is below it, and around 35% of the data is above it. And that's what it means. It's 65% of the way through the data if you're going from smallest to biggest. Okay, so last question on percentiles. What is P88 for this data set? So first of all, you're going to have to calculate the position of P88 and then work out the value. So what's the position going to be? I'm kind of certain it's going to be towards the end here because 88 percentile is quite a long way through the data. So what is, so I know this is going to be n plus 1. So what's that going to be? 26.4. And since I'm rounding, I'm going to round to the 26th position. And it would be silly to count 26 from the beginning because it would take me a long time. Remember, this is the 29th position. So if that's 29, what is the 26th position for your answer? Ntombi says 58. Loretta says 58. Who else? Okay, lots of people say 58. So I'm getting the impression, let me just check that. So this is the 29th, 28th, 27th, 26th. So that is P88. And according to the stem and leaf plot, the stem is 50, that's 8. So the value is 58. So Barbara, what I first had to do was for the 88th percentile, I worked out its position. And I used the formula, whatever the percentile value is over 100 times n plus 1, where n is the number of items in the data set. We got a value of 26.4, but because 26.4, when you round it, you round down to 26. It's the 26th position. And then because there were 29 items in the data set, I just went backwards, like 29, 28, 27, 26. So that would be the 26th item in the list, and its value is 58. So that looks good to me. So in future, if they had to say, often in like statistical tests, they'll say about the 95th percentile, that's a particularly important one. But you guys should always have now the knowledge to work out the different percentile values. And it's just the simple structure. What is the position? Round off, and then find a value in the list that corresponds to that position. Okay, cool. Let's move on. So what I'm going to do now is I'm going to talk about something called the standard deviation, and probably your calculator is going to be quite useful. And I'll explain why in a moment. So what is the standard deviation? You can do it manually or with a calculator, but in reality, like 97% of the exams I've ever seen always ask you to use your calculator to find the standard deviation, and then apply your knowledge of what the standard deviation is to answer a question. So if they manually want you to do it, it just takes too much time, or they basically fill in most of the work for you and you just plug it into the formula. And that's all it ends up being. The more difficult thing in my experience is teaching students how to use the calculator to find the standard deviation and get comfortable with that. So that's what I'm going to do now. What happens in the standard deviation, though, is, just to make sense of this formula, is each data item, xi, is subtracted from the mean. The mean is this figure u here. And what that gives you, it gives you a difference, how far away something is from the mean. Now, because that mean can be positive or negative, we square it. But now, if we've squared it, at some later stage, we have to square root it to undo everything. The sigma sign is just summing up all the differences. And the dividing by n is just the number of items in the data set. So in the previous example, n was 29. So you could go through and have a long table where you did this, but your calculator can do that all for you. And so let's have a look at how that would work. And so what I'm going to do is I'm going to bring up my calculator in a moment. So here is a typical exam question that I took from an old exam. I think it was about 4 marks. Given the data below, work out the mean and the standard deviation. Now, the mean is a measure of central tendency. It is where the middle of the data is, whereas the standard deviation is a measure of spread or dispersion. It's measuring how spread out is the data. Both of these can be done on your calculators. And so let me try and bring my calculator up now to help you see what's going on. So give me a thumbs up if you can see my calculator on the board. I had to do a little bit of technical checking, but I'm glad to say that I have my calculator to demonstrate this. Okay, so what do we have to do to find the standard deviation with our calculator? We click mode. So that was the step 1. So mode. Now my calculator's going to be funny. Mode. And then we hit 2 for stat mode. So mode and then 2. And then we hit 1 for var, which is also called sort of related to the variance. And you should then get a place where you can put your data into the calculator. So that's what I want you to do now. I want you to take your calculator and I want you to start putting the data in. And how do you do this? You go 356 equals 525 equals 743 equals. And you just keep doing that for all the data items. There are 12 data items. So I want everyone to put that into their calculator, and then we'll talk again once you've done that, because I need to do the same thing. So 2, 5, 6, 2, 1, 2, 1, 9. Just be careful you don't make a silly mistake. Then 4, 8, 6, 1, 3, 4, 8, 5, 8, 6, 5 equals. Okay, so in Paul, all we've done so far is we hit mode 2 and then 1, and we're putting these data items that you can see on the screen into my memory of my calculator. And you'll see there's a little stat button at the top here. Now, once you've entered these 12 data items, there's another step that you need to do. And in order to access that, you have to hit the AC button on your calculator. So I'm hitting AC. And then what I do is I go Shift and 1. So I suppose I should write that. There's just too many flipping things on my screens right now. Sorry, guys. I'm going to have to use my mouse to do this. Shift and then 1. So I went Shift 1, and you should get that screen. And then out of the items that you have here, you choose 4. So notice how I'm putting the whole list of commands up on the board for you. So Shift 1, 4. And, oh, did I hit the wrong? Let me go back again. So Shift 1, then I hit 4. And given out of these symbols that are here, the 3 is the standard deviation. So I hit 3. And then after I've hit 3, I'm going to hit equals. Okay, so 3, and then I hit equals. And you should be getting a standard deviation of 220.20. So sigma should be 220.20. So if you get that answer, just put it in the chat so I can see, or if you need me to do it again, just let me know. So your standard deviation for this data set should be 220.20. Okay. So if we think about, I'm not going back to the very beginning, but so just to show you, if I go Shift 1, then 2, my data is already there. It's been entered. So I then hit AC. Okay, so now that's when I'm actually going to get my values. And so I hit Shift 1. And then after Shift 1, I hit 4. And then to get the standard deviation, I hit 3. And then I go equals. So I'm actually giving you that at the top here. If you look at the kind of stay co-host. I really have a lot of things on the screen. Shift 1, 4, 3 is that last bit of stuff we have to do. And to put it into the data into our calculator, we have to do this. Now, that's not the only question that they asked. They asked for the mean using your calculator. And in order to find the mean, you just hit AC again. You go Shift 1, 4, but this time you don't hit 3. Can you see that the mean is like this X bar thing? You hit 2. Okay, so you hit 2, and then you hit equals. So just check that you get that mean of 501 for this data set. We have the mean. Check that you get that. Okay, so what I've been showing you now is how to calculate mainly the standard deviation using your calculator, but you can also get the mean. But If the data set is very, very small, often what we do is we just add up the items and divide by the number of items. It feels like overkill to use your calculator. But for the standard deviation, your calculator is definitely your friend. Okay, so Tsunolo, for the mean, I hit Shift 1, and then it's still 4. So we always go to the variance menu, 4. And then instead of hitting a 3 for the standard deviation, you'll see there's like an X with a bar on top. And we hit 2. And then I go equals. Okay. So what I want to suggest is, guys, we're going to do another practice example of this. Take a screenshot if you need to of this is the magic instructions. Now, the problem is when you go on to the next question, you need to make sure that your memory is clear. So how do you clear your memory? And probably the easiest way to do it is just to hit mode and hit 1. And when you hit that, when you go back into normal mode, so it's not statistical mode, it clears your memory automatically. So now if you go mode 2, 1, you'll see that the data set is completely not there anymore. And so that's what you're going to have to do for the next question. Okay. So Sarah, you got 501.166. You shouldn't have got that. Let's see if that carries on happening. Maybe there was like maybe you put one extra, maybe you made a small error in your data entry. Okay, let's do this one. Here is a multiple choice question. And in this multiple choice question, you are given 10 marks for an end of your exam, and you have to calculate the standard deviation of this data set. Now, the first 3 steps are going to be mode 2, 1, and you should get what you see on the screen. And then I want you to see if you can remember the steps to find the standard deviation. Okay, off you go. And if you are uncertain, you can raise your hand, but let's see if we can work out what the standard deviation is using what we saw before. So you probably start by going like 23 equals 37 equals. The other thing about the standard deviation is the order doesn't really matter. The order doesn't matter for the standard deviation. So in that sense, you can enter it in what it happens to be arranged in order here, but you don't have to have it in perfect order for the standard deviation. Okay, so there's my 10 data items. I hit AC, then I go Shift 1, 4, 3. And I should get 16.87, which would then be 16.9 according to the rounding. And so the answer should be C. Just for fun, work out what the mean is for this data set. So this question asks you for the standard deviation. The right answer is C. I want to know, what is the mean? Work out the mean for the same data set and pop that in the chat. So if I want the mean, I just go Shift, Stat, 4, and then I choose 2. And you should get a mean of 56. So Sarah, just check that you get 56 for that. And we can see then if you are getting, if there's anything wrong with your calculator or something. Okay, Kevin, Rachel, you're getting 56 to Nolo. Awesome. Okay, let's do one more standard deviation question here. And then we'll move on to the second part of the lesson. So I want you, it says here, a booklet has 12 pages with the following number of words. What is the standard deviation number of words per page? And I want you to work that out. Remember now, you have to empty the data set in your memory. Okay, so how do you empty it? There's a couple of different ways, but probably the most practical, the quickest way is just to, well, if it's even the quickest, but it seems the simplest to me. Go like that. So find me the standard deviation for this question. Nizola, I can absolutely do it slower. So if I look at what I was doing when I started, when I turn on my calculator, okay, normally it's in, well, you see a little D at the top. In this case, because I'm doing standard deviation, I change it to the statistical mode. So I go mode 2, and then I choose the top one. Now this does look a bit strange, but you have to choose 1. And then you have your data set. And in this case, I would have to put in 271, then go equals, because that's just the first data item. Second data item is 354. And I go equals, and I do that for all the data. And then I hit AC. And that basically gets me back to the normal screen. I go Shift 1, and you can kind of see there's a yellow stat on the 1 button. And then again, I'm going to choose var or 4. And then I would choose 3 and then equals. Now I haven't put all the data in, so I'm going to have to use the answers to help me to see what the answers are. You should be getting 22.6 or A. That should be your answer. So as we come to the end of the first half of the lesson, standard deviation often comes up. In fact, it comes up in sort of 80 to 90% of the exams. Normally, they will ask you to find the standard deviation in the first part of the question. And then the second part of the question will ask you something about the standard deviation. Now, we'll pick that up in a later lesson. All I want to know for today is that you guys are comfortable finding the standard deviation with your calculator. That was my goal. And so I just want to have a quick class check. Thumbs up if you feel comfortable. Thumbs down if you're not comfortable. But remember, you've always got the recording to watch as well. Okay. Awesome. Okay, so even if you're a little bit confused still, it just takes some practice, but you have the recording available, and once you've got this, it's really quite straightforward. Then we can start talking in later lessons about how do we interpret where it says like how many items are within one standard deviation of the mean and all that stuff. Okay, it's past. I think it's time for some stretching. And so what I want to ask you to do is to turn on your camera and to stand up and stretch your best stretch. And I'm going to join you very shortly. I just want to make sure I'm back to just OneNote and not the calculator. And then, yeah, Lebo, if you could please encourage our students to invest in themselves, as I always say. Oh, that feels awesome.
Oh, yeah.
Oh, I can't tell you how good that feels.
Your body gets so stiff, actually, from just sitting for that long.
Yes, it is. So then I think about a normal school day. So this is what, in class, with my students, I always get them, like, I irritate them because they're like, no, we just want to sit. But I'm like, I don't care. Like, dry your eyes on your feet. It's basically.
No, this is good. This is good.
Yeah.
Well done, guys. Shout out to Rachel, Nizo, Mason, Dombi.
Oh.
Tabi saying, I hope you're stretching.
There we go. Someone's dancing. Oh, I need to get to that point. Yeah.
Kevin says he's disabled. I was worried for a second there.
Okay.
I think he's joking though.
So here's your brain break for today. You need to tell me what this is over here. What is the magic number up here? What is the magic number up there? I think you guys have got this. It looks like it. So that was my hint, was going to be this. And so, okay, so maybe today's was a little bit easy. So all you had to do to get to the next level is to multiply two adjacent blocks to move up. So in theory, following this pattern, you should multiply these two together to get that. So what do we have for that? 12 times by 18 gives you 216. And I think from what I'm seeing in the chat, Sarah, Mason, Masindi, Sihau, Borgeka, Hariva, everyone is looking very happy with 216. So clearly I need to make the brain breaks a wee bit tougher. And so I will look at doing that for the next time. Do you know what, guys? You did so well with the stretching. I think you should stretch one more time just to make sure you've got the most stretchiness that you can. So just make sure you do one more little stretch, and then we will get going with the second half of the lesson. Okay. And just stretch out your neck as well.
I heard a few clicks when I did that.
Yeah. That's good. Good man. Thanks. Okay, so as we move into the second part of the lesson, we are going to talk about 5 number summaries and the box and whisker plot. So you'll often see either you'll be given the 5 number summary, or you'll have to work it out, and then using the numbers in the 5 number summary, you'll draw the box and whisker plot. So let's just start with that. Let's just make sure that you guys all know how to find me a 5 number summary. So what is the 5 number summary? It's just going to be the minimum value, Q1, Q2, Q3, and max. So over to you guys. For this particular data set, I want you to find me those 5 values. Off you go. And if you have a question, I will gladly answer it. But until that point, I'm letting you fly solo, because we have covered this basic idea before. But if there are questions, I would love to talk to you. So here's your data set. I've been so nice as to order it for you, so it's already going from smallest to biggest. You need to find me the 5 number summary for this data set. And these are the items in the 5 number summary. Smallest value, the biggest value, and basically the quartiles. Let's have a look. What have we got? Okay, so Rachel, I agree with you on the min and the max. I suppose the min and the max are probably the most straightforward. So that's good news. For Q1, Q2, and Q3, don't forget you have to find the position, huh? So you need to do a calculation between these where you find the position. And what else might be helpful is if you knew how many items there were. So 1, 2, 9, 10, 11, 12, 13, 14, 15. So n, or the number of items in the data set, is going to be 15. So that could be quite helpful in our calculations, especially the position calculations. I think it could be helpful. See what you guys are getting there. Okay, so a couple of answers coming through in the chat. It's interesting. So use Yes. So see if you agree with my positions. See if you agree with the positions. Now, the positions are not the value, they're just the position. How can you find the actual the value of Q1, Q2, Q3, and so on? Okay, so the fourth position is Q1. And if I count with I get that value over there as Q1. So I'll put a yellow there. The eighth position is here. So I'll put a thing there. And the 12th position is here. So what do we get for our 5-number summary? I get a 507 for Q1. And then I will get a 510 for Q2. We will get a 515 for Q3. And the min should be 503. And the max should be 526. Okay, so good news is finding the 5-number summary isn't horrendously difficult. They do sometimes present in different ways. So sometimes they write it like this. Sometimes they just give it to you like this, where they go 503, 507, and 515, 526. And if they say this is the 5-number summary, you need to know that that's min, that's Q1, Q2, Q3, and max. Okay, so you will find many 5-number summaries, and sometimes they'll even give you the data of the 5-number summary. But just a quick little check. Thumbs up if you feel like you can find the 5-number summary. Thumbs down if you still need more support on finding the 5-number summary. Okay, good. So the next part we need to do is we need to draw a box and whisker plot using the information from the 5-number summary. So basically, the box and whisker plot is a graphical example of the 5-number summary. It basically just shows us the information. And the way it looks, I'll even do it like this, is it basically has, it has the minimum at the end of the whisker and the maximum at the top. And then it has, at the beginning of the box, it has Q1, at the end of the box, Q2, and then the line inside the box, sorry, it's not, it's Q3 here. And then in the middle is Q2. It'll probably be easier if I actually just do a example. So let's draw a box and whisker plot. I'll do it, and then you guys can do the next one after this. So how would I go about actually drawing my box and whisker plot? Now, generally, you would need a number line of some sort. And that number line would have to cover a certain range. So what is the range of my data? Well, we know how to work out what range is. We've done this before. Range is just the biggest minus the smallest. So 526 minus 503, which is, so 526 minus 503, that's going to be 23. And since I basically want my number line to have a range, so I find the range just so I know roughly how many items I need on my data set. And so since it's 23, maybe I'd make it 25 or 30. And I need to have a number line that basically starts at before my lowest value, which is 503. So maybe I'd start at 500. And because I can see that if I go up in twos, it'll probably fit, I'm going to do that. So I'll go 502. Normally in exams, they would give this to you. And so sometimes, I'm actually struggling to fit it in here. Let me zoom in a bit. So you generally would have a pre-printed number line. So 512. This takes longer than I expected. 522. 526. 8. I want to flip them around. Okay, so my scale's not perfect, but the basic idea is there. So how do we actually draw a box and whisker plot? Now, in the real world, what you would do is you just want to make sure you have enough space for every item in your data set. Now, how do I actually go about drawing this box and whisker plot? So what I like to do, different ways to do it, I focus initially on this bit over here, Q1, Q2, and Q3. So where is 507? So 507 is going to be over here. So I draw a line for that. And 515 is going to be over here. So I make two things like that. And then I also do a line for Q2, which is 510, which is going to be over here. And then what I do is I draw a box that links these three together. Okay, so remember, Q1 is over here, Q3 was over here, and then I just drew straight vertical lines for these guys. So I've done those three. Now, what is the remaining bit? So the remaining bit is 503, which is the minimum value, which is going to be down here. And 526 is going to be all the way up here. And so I draw a line from here to here, and I draw a line from here to here. And so this would be my min and my max value. So this graph is called a box and whisker plot, and often you are required to draw them. The other thing is the box and whisker plot shows you visually what's going on with the data set. So as an example, I can see that the top 25% of data, can you see how spread out it is? So the top 25% of data is very spread out. It's got a big range, whereas the bottom 25% of data is actually quite close together. It's very hard to see that if you don't have a box and whisker plots. In fact, the 25% of data between Q1 and Q2 looks the most squashed of all. Okay, I'm probably saying a little bit too much in terms of interpretation. Give me a thumbs up in the chat if you understand how to draw a box and whisker from that explanation and you just want to do an example now. Okay. I was going to say thumbs down if you feel a bit, no. Okay. So I think I've given you an example. What you're going to do now is you're going to go ahead and draw a box and whisker. We'll talk about skewness in the next lesson, Kevin, but yes, it is skewed to the right. That is correct, yeah. Okay, so here is your example. I'm giving you this data set. In fact, to save you time, okay, what I was going to do is I was going to give you the data set in the wrong order, right? So the data is mixed up. But because time is short tonight, I will order the data set for you. So being a nice teacher. What I want you to do is I want you to work out the 5-number summary. So work out the 5-number summary for this data set. And then once you've done the 5-number summary, I want you to draw a box and whisker plot like I've got here at the bottom. Well, I haven't got it yet. I'm going to do it for you. But I want you to try and draw one. And so that's all we're going to do in the remaining time of the lesson. So let's get going. Over to you guys. So in order to draw a box and whisker, you first need to find these 5 values, and then you can go about drawing the box and whisker plot. I'll give you some time. I'll get some water. Yeah, Rachel, I agree with you. The min and the max are like wonderfully simple to work out, aren't they? Now, how many items are there? So n is going to be 12 for the data set. Okay, so now remember, because we are dealing with quartiles here, we're not dealing with percentiles. There is some, remember that the sort of rules are a bit different. So we know that Q1 should be here. 6. Q2 is going to be here. This is 7, 8, 9, 10. Q3 is going to be here. So bear in mind that your position values are falling between 2 values. And for quartiles, what does that mean? It means you need to take the average of the 2 values on each side. The good news is, for the first one, Q1 is going to be 4. Okay, so once you've got your 5-number summary, you guys can start drawing your box and whisker plot. Okay. So Rachel, be careful, because Q2 falls between 10 and 11, you're actually going to need to get 10 and a half. With percentiles, we round to the nearest value. With quartiles, I know it's a little bit strange, quartiles, you have to average out the values that are closest. So it's slightly different between quartiles and percentiles. So Q2 indeed will be 10.5 and Q3 will be 15 because it's halfway between. So, essentially 14 plus 16 divided by 2. Okay. Pleasure, Rachel, pleasure. So once we have got this 5-number summary, you then need to think, okay, I need to draw a number line that allows me to draw a box and whisker. And so what I did last time is I said, what's the range? Well, the range in this case is 15 units. So you're going to have 15 units spaced out here. 1, 2, 3, 4. Actually, we have space to just go up in 1s if you want, or you could go up in 2s if you prefer that. It doesn't matter as long as you're consistent. I think I'm going to go up in 2s just because of time. So I'll start here with 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and I'm already far enough up. So I'm only using, if I had more time, I would have gone up in ones, but it doesn't really, as long as your scale is consistent, it's fine. So now I want you to draw your box and whisker plot that goes with your number line. And I want to give you a bit more time to do that. What I did previously was I drew lines for Q1, Q2, and Q3, and I drew them first on my number line. And then from there, I drew my box. So that's the tip I'm giving you guys. And then once you've done those three, you can get the whiskers. Okay, so Q1 is 4. So I'm going to draw a line for where there's a 4. Q2 was 10.5. Now, because 11 is in the middle, it has to be a little bit more to the left. So that'll be Q2. And Q3 was 15. So that would be over there. What I'm doing then is I'm drawing the box to go there. Then the smallest value is 3. So that's going to be over here. And then the highest value was 18. So that's going to be up here. Okay. And so what we see there is maybe because of the scale I used, it's looking a little bit wonky. But I can always actually zoom in a bit to correct that. But your data set should be looking roughly like that. So if you're methodical and you follow this process, a box and whisker plot is, it's not the most difficult thing in the world. You have to do the working out first, and then you plot your 5 points, and you just make sure you do it in the correct order. Now, in the next lesson, what we're going to do is we're going to start interpreting box and whiskers. So instead of having to do all the working out, you will be given box and whiskers, and you then need to interpret what's going on. So an example maybe here would be which 25% of the data is in the narrowest range. So I'm not sure if that makes complete sense to you, but if I look at the data set here, I can visually see that each line divides up 25% of the data, right? So between here and here is 25% of the data. Between here and here is 25%. Between here and here is 25% of the data, and between here and here. I could ask you for this data set, which 25% of the data is the most tightly together? And if I had to look at this box and whisker, it's the data between the minimum value and Q1 that is the most tightly squeezed together, or it has the smallest range, would be another way of saying it. So that's what we'll start to move into in the next lesson. We'll start to look at how do we interpret box and whisker plots. All right, I want to leave a little bit of time for any additional questions or comments from the class. Are there any questions or comments before we bring the lesson to a close and we ask you to do a poll? In revising what we did today, we did percentiles to start with. We then talked about calculating the standard deviation, which was basically a measure of spread, or how spread out the data is. We looked at something called the 5-number summary. And then we looked at the graph that we can draw from generating a 5-number summary. And this graph is called the box and whisker plot. In the next lesson, we'll look at things like, let's give you a little preview, a sneak preview. We'll look at interpreting. If I give you a box and whisker plot, can you interpret information from the box and whisker plot? So here's an example. Find the interquartile range from this box and whisker plot. And in that you need to know that that's Q1, that's Q3. And so the interquartile range is just the distance between here and here. But we'll talk about that a bit more in the next lesson. Okay, so Bongeka is asking about skewness. Bongeka, you can see in the next lesson, we have some stuff on skewness. And so we'll talk a little bit about skewness in the next lesson. It's an interpretive type question. We'll get to that. All right, Lebo, if you could please put the poll out to the students. See how we are doing the ogive in lessons 6 and 7.